Hello, I am Aniket from Tarkashastra Academy. In this video, we are going to understand the process of finding out HCF and LCM. As you understand, this is basics of mathematics and this is session number 2. You need to understand that this is not the level of questions that will be asked in the exam. You will have to put in a lot of effort to crack the questions because the level of difficulty in the exam is going to be comparatively much higher. But it is necessary that you know the basics of this level because only then you will be able to solve those questions. There will be multiple instructions provided during the sessions. You need to follow those instructions. There will be few quizzes asked in the quiz during the session. You need to pause and solve that quiz. Only then it will be fruitful session for you. Make sure that you go through it and learn something new and implement it in the actual exam. And whatever we have studied in basics of mathematics session 1, we are going to test it here again. So, what is 13 square? It is 169, 17 square, 289, 51 square is 2601, 99 square is 9801, 21 square is 441, 8 cube is 512, 11 square is 121, 11 cube is 1331, 2 raised to 12 is 4096, 8 raised to 0 is 1, 0 raised to 8 is 0. Cube root of 512, cube root of 512 is 8, 0 square is 0, 85 square is 8 into 9, 72, 25. Under root of 289 is 17. 19 square 361, under root of 384 is 18, 12 cube is 1728, 31 square is 961, root 256 is 16, 12 square 144, 55 square is 3025, 111 square is 12321, under root of 625 is 25, under root of 115 square is 13225, 7 cube 343, root 841 is 29, 3 raised to 5 is 3 raised to 5 is 243, 11 raised to 4 is 14641, cube root of 729 is 9, 71 square, 71 square, 71 square is, this is 1, this is 14, 1 carry, 5041. 3 raised to 4 is 81, 13 square 169, cube root of 125, 5, 140 square is 196, 00. 2 raised to 7, 2 raised to 7, 2 raised to 7 will be 128. 5 raised to 4 is 625, 11 cube 1331, cube root of 2166, this is 8, this is 3. 2 raised to 8 is 512, 32 square is 1024, cube root of 3375 is 15, 101 square 122, 10201, 22 square 484, 2 raised to 9, 512, 5 raised to 5 is 3125, 30 cube is 927 and then 000, 15 cube is 3375, 17 square is 289, followed by fifth root of 1024, it's 4. Okay. I hope you have got all the answers correct. You were supposed to pause the video and then go ahead with it. Now moving forward, the basic thing that you need to understand to solve to solve HCF and LCM is to find out the prime factorization of the numbers. For example, 24. In our childhood, what we used to do, 24 divided by 2, 12, divided by 2, 6, again divided by 2, 3, again divided by 3, 1. So this is 2 cube, I know, because 2 is coming 3 times, and then 3 raised to 1. Okay, this is our final answer, 2 cube into 3 raised to 1. 2 cube into 3 raised to 1. Now 2 cube into 3 raised to 1 is the prime factorization because the bases are prime. This is the prime factorization because the bases are prime. Then 36, if I have to calculate, this is 6 square, which is 2 into 3 whole square, which is 2 square into 3 square. Now you need to understand this method or this method, both the methods are correct. What we are interested in is this final step. This is what I should get in the final step. That is what is my expectation is. Okay. Let us say if I have to calculate prime factorization of 144, it is 12 square, which is 4 into 3 square, which is 2 square into 3 square, which is 2 raised to 4 into 3 square. So 144 is 2 raised to 4 into 3 square. 2 raised to 4 into 3 square. That is how we need to find out the prime factorization of the numbers. Okay, this is the prime factorization. Let us say if they ask me to find out the prime factorization of 512, what I do, I'll divide it by 2. Then I get 256, again divided by 2, 128, again divided by 2, 64, again divided by 2, 32, divided by 2, 16, divided by 2, 8, again divided by 2, 4, again divided by 2, 2, again divided by 2, 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 512 is 2 raised to 9. Okay, this is the prime factorization. Again, method is not important. The final answer is important. Whichever method you are comfortable in to find out the prime factorization, you utilize that. The thing is, prime factorization should always have the base as prime. For another example, 18 is 2 raised to 1 into 9 raised to 1 is not prime factorization. Reason being, 9 is not a prime number. Reason being, 9 is not a prime number. The prime factorization of 18 will be 2 raised to 1 into 3 square. The basis should be prime. Okay, let us try to find out the prime factorization of these numbers. So we have 460. 460 is 23 into 2 into 10. So that is 2 square, 5 raised to 1 into 23 raised to 1. 1240. 1240 is 124 into 10, which is 31 into 4 into 10. Okay, so this is 2 cube 5. From here we get 2 square into 2 into 5. So that is 2 cube into 5 raised to 1 into 31 raised to 1. Okay, I hope you have understood how to calculate the prime factorization. Okay, it is a necessary step to find out the HCF and LCM. You have to pause the video and try to solve the remaining questions of prime factorization. Only then you will get the idea how to calculate the prime factorization, and then further it will help in HCF and LCM. So please pause the video and try to solve these questions. So 544, I'll have to do it like this. 544 divided by 2, this will be 250, 272, again divided by 2, 136, again divided by 2, 68, again divided by 2, 34, again divided by 2, 17, again divided by 17, 1. So this is 2 raised to 5 into 17 raised to 1. 117 is 9 into 13, which is 3 square into 13. 980 is 49 into 2 into 10. So 10 is what? 2 into 5, no? So 2 square into 5 raised to 1 into 7 square. 49 is 7 square. 6647. 6647. This thing will go by 70. Many of you will get confused. Even I got confused with solving it. So we have to, I am telling you the step directly. It is going to be divisible by 70. So 6647, 6647 divided by 17. 3s are 51. This is 5, 154. 9s are 153. And then 17, 1s are. So 391 is divisible by 70. Now 391, if I have to check, it will be divisible by what? Will it be divisible by 70? 34? Yes. Again, it will be divisible by 70, which will give me 23. Then again, divisible by 23, remainder 1. So 6647 is 17 square into 23 raised to 1. 820 is easy. This is 21 fours are and 10. It's as it is. So that is 2 cube. Not because this is 2 into 5 and this is 2 square. So 2 cube into 3 raised to 1, 5 raised to 1, 7 raised to 1. That's simple. Then we have 2475. 2475. 2475. Let us try to do it using this method. 2475. Is it divisible by 6? So this is 6 plus 7, 13. It is divisible by 3. So 825, again divisible by 3. 275, again divisible by 5. It will be 55 divisible by 5, 11, 11. This will be 1. So 3 cube into 5 square in, no, 3 square into 5 square into 11 raised to 1. Next, what we have 5005. 5005. What do we understand from 5005? Let us try to understand that. 5005. Prime factorization divided by 5, 1001. Now 1001 is not divisible by 3. Will it be divisible by 7, 98, 21? Yes. It will be divisible by 7. So if I divide by 7, 14, 143. Then divisible by 11, 13. Then divisible by 13, 1. So this is 5 raised to 1, 7 raised to 1, 11 raised to 1, and 13 raised to 1. Then 56 is very easy. It is 8 into 7. 8 into 7 is 2 cube into 7 raised to 1. So this is how you need to go ahead with the prime factorization. Now, if you have understood the prime factorization, you will understand the HCF and LCM quite easily. Okay, so let us go ahead with the HCF and LCM. So let us understand what is HCF and LCM. Let us try to understand this with the help of an example. Let us take two numbers 24 and 36. What are the factors of 24? 1, 2, 3, 4. Now, what do we understand by factors? Factors are those numbers in which the actual number, I mean, in this 4's table, 24 will come. In 6's table, 24 will come. 8's table, 24 will come. 12 will come in 20, 24 will come in 12's table as well, and also in 24's table. Okay, what are the factors of 36? 1, 2, 3, 4, 6, 9, 12, 18, and 36. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, correct. Now, you must have understood that factors are less than the numbers. Yes or no? So, factors of 24 are less than or equal to the number. So, 1 is less than 24, 2 is less than 24, 3 is less than 24. Now, similarly for 36, 1 is less than 36, 2 is less than 36, 6 is less than 36, 12 and 18 are less than 36. So first thing that we understand is that factors are generally less than the numbers. Okay. Now, between 34, so this is what we have understood by factors. Now let us try to understand common factors. So between 36 and 24, 1 is common, 2 is common, 3 is common, 4 is common, 6 is common, and then 12 is common. Okay. So these are your common factors. Now let us try to understand highest. So highest common factor is 12. Highest common factor is 12. Okay. So what we understand, HCF is generally less than or equal to the numbers. So these are my numbers N1 and N2. HCF is less than or equal to that numbers. Okay. And HCF is formed from the factors. Okay. Now let us try to consider LCM. Again, let us take two numbers 4 and 6. So the table of 4 is 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, and so on. These are known as multiples. Okay, these are known as multiples. So we understand what is M. M is multiples. Multiples are greater than the numbers. If you look at 6 multiples, 6, 12, 18, 24, 30, 36, 42, 48, and so on. Okay, so numbers are generally lesser than or equal to the multiples. Okay, so we understand multiples, what are multiples, and we also understand that multiples are greater than the numbers. Now, the common multiples, 12 is common, then 24 is also common, 36 is also common. If we go ahead, we will get 48 also common. Then we will get 60 common, and it will go up. And it will go up. There will be unlimited multiples. Okay. And these are your common multiples. 12, 24, 36, 48 are your common multiples. Okay. But now the least common multiple or lowest common multiple is 12. Of all the common multiples, the least one is your LCM. Okay, so this is what we understand by LCM. Now, HCF is generally smaller than the number. LCM is generally greater than the numbers. LCM is generally greater than the numbers. If you observe, the LCM is greater than the numbers. Okay, LCM 12 is greater than 4 and 6. Okay, so I hope you have understood what is HCF and LCM. HCF sometimes is known as greatest common divisor. So factors and divisors are one and the same thing. Factors and divisors are one and the same thing. Okay, moving forward, this is what we have understood, HCF and LCM. Now, how to calculate this HCF and LCM? Let us try to understand it. So, HCF and LCM. Let us calculate it for 24 and 36. We know that prime factorization of 24 is 2 cube into 3 raised to 1. We have already calculated it. Prime factorization of 36 is 2 square into 3 square. We have calculated this as well. Okay. What will be the HCF? HCF will be all the chota factors. So 2 cube and 2 square में chota factor 2 square. 3 raised to 1, 3 raised to 2, chota factor 3 raised to 1. So that is 4 into 3, 12 is the HCF. Okay, in HCF we consider chota factors. Then comes LCM. In LCM we consider all the bada factors or greater factors. So 2 cube and 2 square, greater factor 2 cube. 3 raised to 1, 3 raised to 2, greater factor 3 raised to 2. So total 2 cube into 3 square, that is 8 into 9, 72 is the LCM. 72 is the LCM. Okay, this is what we understand from HCF and LCM. Okay, let us say I have two numbers for which the prime factorization is available. Let us say 2 cube into 3 square into 5 raised to 2. And here we have 2 square, 3 cube, 5 raised to 5. Okay, what will be the HCF? HCF will be 2 cube and 2 square. Chota factor 2 square, 3 square, 3 cube, chota factor 3 square, 5 raised to 2, 5 raised to 5, chota factor 5 raised to 2. This will help you find out the HCF. All the chota factors will help you find out the HCF. Now, if we consider LCM, we consider all the greater factors. 2 cube and 2 square, greater factor 2 cube, 3 square and 3 cube, greater factor 3 cube, 5 raised to 2, 5 raised to 5, greater factor 5 raised to 5. Okay, greater factor 5 raised to 5. So this is how we find out HCF and LCM. Now, there are few things that you need to take care of, N1 and N2. Here we have 2 square, 3 raised to 4, 5 raised to 1, and 7 raised to 2. And here we have 2 square, 3 raised to 4, 5 raised to 6, and 7 raised to 2. Now, 2 square is common, 7 square is also common. So, to find out HCF, which one is greater? 2 square and 2 square, both are same. So, we consider it as it is. 3 raised to 4, 3 raised to 4, both are same. So, we consider it as it is. 5 raised to 1, 5 raised to 6, chota factor 5 raised to 1. 7 square, both are same. So, we consider as it is. Okay. Next is LCM. 2 square, greater factor. There is nothing greater, so we consider it as it is. 3 raised to 4, 3 raised to 4, both are same, so we consider it as it is. 5 raised to 1, 5 raised to 6, both are same, we consider it as it is. 7 square, both are same, we consider it as it is. Okay, so when the powers are same, we consider it as it is both in HCF and in LCM. Okay, moving forward. So, now let us say we have N1 and N2. Here we have 2 square, 3 raised to 4, 5 raised to 2. And here we have 2 cube, 3 square, 5 raised to 4. No, 7 raised to 4. Now what do we do in such cases? So HCF, chota power 2 square, chota power 3 square. Now here we have 5 raised to 2. I can write 5 raised to 0 because anything raised to 0 is 1. So 5 raised to 0 is also 1. And I can multiply any value by 1. I get the same value. Similarly, here I have 7 raised to 4 and I don't have anything here. So I can write it like this, 7 raised to 0. I can write it like this, 7 raised to 0. Correct. So what is the chota power? 5 raised to 0 and 7 raised to 0. Correct. LCM, 2 cube, 3 raised to 4. Bada power 5 raised to 2, 7 raised to 4. As simple as that. Okay. So when the numbers are missing, when the numbers or factors are missing, we take 5 raised to 0. Okay, we take 5 raised to 0. You will understand it more once you start solving the questions. Okay. So whatever you have understood, try to solve it using the using your knowledge. Make sure that you put in you find out the prime factors first, and from that you find out the HCF and LCM. First, you need to find out the prime factors and then HCF and LCM. Okay, so first find out the prime factors of 60, prime factorization of 60. So what is the prime factorization of 60? Can you calculate that? Okay, you all need to pause the video and then try to solve it. First, we have 60. So 60 is 12 fives. So that is 2 2 square, 3 raised to 1, 5 raised to 1. 72 is 18 to 9. That is 2 cube into 3 square. What will be the HCF? HCF will be very easy. It will be chota power 2 square, 3 raised to 1, 3 raised to 2, chota power 3 raised to 1. And here we have 5 raised to 1 and nothing. So 5 raised to 0. Okay, in HCF we make that arrangement. LCM, we take the greater powers or bada powers. So 2 cube into 3 square into 5 raised to 1 will be the LCM. Second, we have 126 and 162. So what is the prime factorization of 126? Let us try to find that out. Prime factorization of 126. 126 is 49. So 2 raised to 1, 7 raised to 1 into 3 square. 162 is how much? 162 is 81 twos. So 81 twos is 2 raised to 1 into 3 raised to 4. Okay, so HCF will be 2 raised to 1 and then 3 square. Here we have 7 raised to 1 and here we have nothing, 7 raised to 0. So we'll take 7 raised to 0, chota power. To find out LCM, we'll have 2 raised to 1 as it is, 3 raised to 4 greater power, 7 raised to 1 greater power. Okay. Then comes the third one. Let us try to find out the third one. Third one is 900 and 270. 900 is 9 into 100. That is 9 into 100. So that will be 2 square into 3 square into 5 square. And 270 is 27 into 10. So that is 2 raised to 1, 3 cube into 5 raised to 1. Simple. HCF 2 raised to 1, chota power. 3 raised to 2, 5 raised to 1. LCM, bada power. 2 square, 3 cube and 5 square. I hope you have solved all the questions and then checking the answers. Fourth is 300 and 550. What is the prime factorization of 300? You can calculate. It comes out to be 2 square, 3 raised to 1, 5 raised to 2. 550 is 2 raised to 1, 3 square into 5 square. So HCF is chota power 2 raised to 1, chota power 3 raised to 1, and 5 raised to 2, 5 raised to 2. So we take it as it is. LCM, bada power 2 square, bada power 3 square, and 5 raised to 2, 5 raised to 2 as it is. So we take it as it is. Then we have what? Fifth one. Let us say try to do it here. 320 and 128. So 320 is 32 into or 64 into 5. So that is 2 raised to 6 into 5 raised to 1. 128 is 2 raised to 7. HCF is simple. 2 raised to 6 because we don't have 5. So 5 raised to 0. 2 raised to 6 into 5 raised to 0. LCM will be greater power of 2 raised to 6 and 2 raised to 7. That is 2 raised to 7 and 5 raised to 1. Okay, this is how we can calculate the LCM. Okay. Now, moving forward, we have three digits for which we have to calculate. Sixth one is 70. 70 is easy, 2 raised to 1, 5 raised to 1, 7 raised to 1. Then next is 80. 80 is also easy, 2 raised to 4 into 5 raised to 1. And 120. 120 is also easy. 120 will be 2 cube into 3 raised to 1, 5 raised to 1. 2 cube into 3 raised to 1, 5 raised to 1. What will be the HCF? Chota power 2 raised to 1, chota power 5 raised to 1. And then we don't have 7. So we can write 7 raised to 0 here and 7 raised to 0 here. Hera. Now start to omit this 7 raised to 0. LCM, greater power 2 raised to 4, 5 raised to 1, 3 raised to 1, and 7 raised to 1. Okay, 3 raised to 1 is here. We don't have 3 anywhere else. So 3 raised to 0, 3 raised to 0. Then we have 7th one, which is 135, 245, and 270. This is very easy. Here what we have, 3 cube into 5 raised to 1. This is 245, it's 49 fives are so 7 square into 5 raised to 1. And here what do we have? 2 raised to 1, 3 cube into 5 raised to 1. Very easy. HCF will be 2 is not present anywhere. So we will consider 2 raised to 0. I mean, it is present here, but not here. So 2 raised to 0, 2 raised to 0. 3 is here, 3 is here, but not here. So 3 raised to 0. So 3 raised to 0 will be considered in HCF. 5 raised to 1, 5 raised to 1, 5 raised to 1 is present everywhere. Here we have 7 square. Here we don't have 7. So 7 raised to 0. 7 raised to 0. Okay. So HCF comes out to be 5 raised to 1. If I consider LCM, highest power of 2, 2 raised to 1. Highest power of 3, 3 raised to 3. Highest power of 5, 5 raised to 1. Highest power of 7, 7 square. This will be the LCM. Okay. 8 is very easy. 32. It is 2 raised to 5. Then we have 48. 48 is 2 raised to 4 into 3 raised to 1. And then we have 54, which is 27 to the. So 3 cube into 2 raised 3 cube into 2 raised to 1. Okay, very easy. HCF will be smallest power of 2, 2 raised to 1. That's it. Smallest power of 2, that is 2 raised to 1. We don't have 3 here, so 3 raised to 0. LCM, highest power of 2, 2 raised to 5. Highest power of 3, 3 raised to 3. Then comes 9th one, 36. It is 2 square into 3 square. 84, 84 it's 2 square into 3 raised to 1, 7 raised to 1. And 128, it's 2 raised to 7. HCF, it's 2 square. That's it. We don't have 3 here and 7 here. LCM will be highest power of 2, highest power of 3, and highest power of 7. Okay, 10th one. Let us try to solve the 10th one here. So 153 is available. 153 is 17 nines are. So 3 square into 17 raised to 1. 187 is 17 11s are. So 11 raised to 1, 17 raised to 1. And 51 is 3 raised to 1 into 17 raised to 1. If we consider HCF, HCF will be highest power of 3, that is 3, lowest power of 3, that is 3 raised to 0, lowest power of 11, that is 11 raised to 0. We have 17 only, so 17 raised to 1 is HCF. LCM will be highest power of 3, 3 square, highest power of 11, which is 11 raised to 1, and then highest power of 17, 17 raised to 1. This is going to be the LCM of 153, 187, and 51. Okay, so the basics of HCF and LCM, I hope, are clear for you. I hope you have utilized the session properly and followed the instructions, because only then you will understand it and you will be able to apply it in the questions further or in the exam level questions. I hope you have understood this thing. Thank you so much. Jai Hind.